CCSP actually stands for Certified Cloud Security Professional. So this particular certification is focused towards the professionals who is going to manage the things in the organization. Suppose an organization wants to migrate or adapt to the cloud, there will be a set of people who is going to support this organization in the cloud adoption and migration by understanding the governance, by understanding the risk, by making sure everything is compliant. So from that perspective, this particular certifications has been launched. This CCSP is a certification and a course provided by ISC2, International Information System Security Consulting Consortium. So now when we talk about CCSP, in CCSP we have 6 domains, right? 6 domains. So what are the 6 domains? We'll see that. So these are the 6 domains we have. These are the 6 domains we have. So domain 1 is cloud concepts and architecture and design requirement. So in this first domain, we're going to discuss about, first of all, everyone is saying cloud. What is cloud? What is cloud? What is the actual definition of cloud? What is the actual definition of cloud? And we're going to also talk about the characteristics, service model, deployment model, and what are the different roles involved in cloud computing under the cloud computing reference architecture as well. And also in the domain 1, we're going to talk about the security considerations of different service model. We're going to talk about threats to cloud computing. We're going to talk about how to evaluate a cloud service provider, as well as we are going to also discuss about the impact of technologies when we bring the cloud into the picture. All these things we are going to discuss under the domain 1. And domain 2 is cloud data security. See, for every organization, one of the most valuable asset is data. So when they move that particular data to the cloud, what are all some of the data security strategies and technologies which we can implement to protect the data when it is moved to the cloud? So we're gonna discuss on that as well here. And also we are going to talk about data security lifecycle. All right, we're also going to talk about little bit of forensics related topic, chain of custody. Then this domain 3, cloud platform and infrastructure security. So far, for the past 2 domains, domain 1 and domain 2, we discussed everything from customer point of view, right? From customer perspective, who's going to consume the cloud. But in this domain 3, we're going to talk about from little bit from provider perspective. So how they are building the cloud data center, right? How they are building the cloud data center, how they are managing the cloud data center, what is the building blocks of the cloud data center. We're going to talk about that infrastructure and their security, as well as, just a minute. Yeah, as well as here in the cloud platform and infrastructure security, we are going to discuss about BCP and DRP. When we bring the cloud into the picture, right? What are the different ways we can able to perform the BCP and DRP? So we're going to talk about 3 scenarios here. And based on the 3 scenarios, we're going to have a discussion related to BCP and DRP. Then domain 4 is cloud application security. When we move an application, on-prem application to the cloud, what are the complexities and challenges we face? We're going to talk about SDLC, secure SDLC, and we're going to talk about OWASP top 10. We're going to talk about some ISO standard for application security management system, different types of threat modeling, and all this kind of thing. Then domain 5, so we have a cloud data center. We have a cloud data center. So this cloud data center, whatever the components we have, for example, we might have a firewall, we might have an IDS, IPS, we have this host, and on top of it, virtualization. So all these things has to be properly secured. So how to do that? That is we are going to discuss in domain 5. As well as we're going to talk about, we have a data center. In the data center, we will be having people, process, technology. So in the data center, if they want to make any changes, it has to go to change management process. People follow the change management process, use the technology to introduce the change. We have patch management. people follow the patch management process using the technology, they're going to introduce the patches. So we're going to talk about from service operational point of view. So we'll be considering an ISO standard called as 20,000 here, which is service management system for this discussion. Then we're going to talk about how to manage the communication with the relevant parties, with the provider and the customer and the vendors and the suppliers. Then we're going to talk about forensics as well here. When we bring the cloud into the picture, how the forensics is going to create a challenge for the customers. Then we have domain 6, right? This domain 6, legal risk and compliance. So here we're going to talk about why we should have a proper cloud governance, policies, standards, procedures, guidelines, baselines, as well as here we are going to talk about different data privacy regulations around the world. A good visibility about the different data privacy regulations around the world. And in this domain 6 only, we're going to also talk about the risk. How to drive the risk management when we bring the cloud into the picture. All these 6 domains actually comprises of your CCSP. And exam, this is actually not correct. They have updated it. Now the length of the exam is 3 hours and the number of questions you will get is 125. It is not a CAT type of exam like CASSP. It is a normal computer based exam. So you will be having multiple choice, scenario based questions as well as straightforward questions. 700 you have to get to pass this exam. So today what we will do, we'll be having a session for around 3 hours or something like that. So up to 12. So today we will start with the domain 1. Okay. So domain 1 is all about cloud concept, architecture, and design requirement. This is domain 1, cloud concepts, architecture, and design requirement. So we already discussed about what is the CCSP abbreviation, Certified Cloud Security Professional, and all these things we already discussed. Okay. So these are the domain 1 objectives and the chapters. Okay, this is domain 2, which I discussed with you, domain 3 and domain 4, domain 5, chapters and topics, domain 6. Okay, this is the exam details which I discussed with you. Now, we'll discuss this who qualify later, but first we'll start with the domain 1. Say domain 1, cloud concepts, architecture and design. In that first we'll be discussing about definition, characteristics, service model, deployment model, cloud computing reference architecture, all this kind of stuff. Okay, so first module 1 under domain 1 is understand cloud computing concept. Yeah, everyone is saying cloud computing. But first of all, what is cloud computing? If I just ask this definition to a networking person, he might have a different view about cloud computing. If I ask this question to a senior management, he might be having a different view about cloud computing. If I ask this question to a security person, he might be having a different perspective of cloud computing. But generally, when we say cloud computing, what is it? Here we have this word called as cloud. Okay, so cloud means remote or network. Computing means what actually comprises of computing? The CPU, memory, RAM, both are same, storage, right, network, all these are computing. So all these are parts of computing. So as a customer remotely through the network, I'm going to access these resources in the form of a service. That is what cloud computing. Very layman definition. But we will also see what is the original, what is the actual definition of cloud computing, and we'll try to see whether it is matching or not. Now, before seeing the actual definition of cloud computing, let's go back a little bit in the history. Okay, in the history. So during the year 2010, at those time, the providers started providing the cloud services. But the customers were very reluctant to try out these new service models. Why? Because for a customer perspective, they don't have a clear visibility what is cloud and what is cloud servers and cloud computing. And for the customer side, they have a lot of questions. So a third party is going to provide the services to us. But if something goes wrong, who is going to be responsible for that? Who will do or perform what activities? If data is stored in the cloud, if it got breached, whom I can blame? So in each of the service model, who is responsible for what? Like this, there are lots of questions were there in the minds of customer. So they were very reluctant to try out this cloud services. Same thing for provider, they not have a visibility. What is the expectation of the customer? What they're actually expecting from us. So what kind of services will be apt for the customers? So that's a problem like this on both sides. So what NIST did, National Institutes of Standards and Technology. If you don't know what is NIST, it is actually funded and managed by US government, right? And NIST actually going to provide or published lots of documents specifically for security, standards, guidelines, best practices. So what NIST did, they just saw this picture, okay, for cloud, there is no proper visibility, no clarity about the cloud services for both the parties. So what they did, they published some documents. Special publication 800-145, special publication 800-146, special publication 500-91, special publication 500-92. This 800-145 in this, they come up with the definition of cloud computing. If anybody is saying cloud computing, this should be the definition. And also they come up with the characteristics of cloud computing, service model and the deployment model. Other documents, they come up with the cloud computing roadmap, synopsis. This one is cloud computing reference architecture like this. These are all actually very good reference document for cloud. But is it mandatory to refer this document for the exam? No, just have an idea about it. That is it. So what NIST did during the year 2010 to 2011, they published these documents specifically for the cloud to give the proper visibility to the provider and the customer. What is cloud? As a customer, what you can expect from the provider? What are the different service model? What are the different deployment models? Based on the customer can decide. That is what actually happened. Now we will see the actual definition of cloud computing. Before that, we will just look in the history how well we were matured right now, because everything started something around somewhere around 1960s to 70s. At those time we were having this thick client terminals, IBM mainframe systems and all. Then in the 80s they introduced the internet desktops. The 90s it was Google was launched, right? And wireless was into the picture. They introduced the virtualization to effectively use the resources. Then during the 2000, the actual cloud was born, right? A third party providing services to the customers. Now we are in 2025. Now these cloud services were very well matured, and now it's keep on getting innovated a lot, right? So this is kind of a path, right, from 2025 back to 1960. So as I told you, this is just the history before 2010 and after 2010. Once the NIST published the documents, for the cloud vendor, it increased the trust, more business, customer ready to experience, huge case repository. For enterprise, satisfied customer, less expenditure, clear contract, clear baseline. Because both the parties got the visibility, what is cloud, what to expect, what not to expect, who is responsible for what, like that. So actually, what is the definition for cloud published by NIST in the 800-145? This is the definition. From here, up to this. I will read and I'll give you the explanation. Cloud computing is a model for enabling ubiquitous. Ubiquitous means it is available everywhere from any location, from any device, you can access it. It's around the world, it is available. Convenient, on demand network access. As a customer through the network, I'm going to access the computing resource which has been shared with multiple tenants. When I say computing resource, what comprises of computing resource? Network, servers, storage, applications, and the services. All these resources will be provided as a service to the user, which can be rapidly provisioned and released with minimal management effort or service provider interaction. So what is it? As I explained to you in layman term, same thing here they have given officially. So as a customer, whenever there is a requirement or the demand through the network, I'm going to access the resources which is shared with multiple tenants, and I'm going to use it. All these things I can do it with minimal management effort or service product interaction. This is the definition they have given. Did I have to memorize this definition for the exam? No, but have an idea about this definition. Clear? This one?
Yes. So this definition is coming from the public cloud perspective, or from private cloud also we can
It's a
uh,
general discussion
look at.
about cloud computing. Even when you talk about private cloud as well, the private cloud is a kind of a data center where we introduce automation and virtualization, all this kind of thing, and we make it a private cloud. This private cloud will also be accessed from people using the network only, right? They're not going to go
Yes.
directly and use it. So absolutely, this definition can be mapped with any forms of the cloud for sure.
Okay.
There's a general definition for cloud computing. So if you see this slide, right, this is NIST definition of cloud computing, but ISO as well, they have actually published some documents specifically for cloud computing as well. Okay, specifically for cloud computing as well. So what is the standard for ISO? ISO 17788, which actually talks about cloud computing vocabulary and the definition. In that, they also come up with the definition of cloud computing. Definition of cloud computing. So what is the definition the ISO 17788 has given here? If you see, this is the definition they have given. Paradigm of enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration of the demand. The same definition, but they use different words. They just paraphrased it and just given the definition of cloud. But ultimately, both are same meaning only. There is a provider who is building the data center, managing the data center, exposing the services. As a customer, based on the demand, based on the requirement, I'm going to access the services through the network. And all these things, I'm going to do it with minimal or manageable effort. And these resources will be shared with multiple tenants. So this is the actual definition of cloud computing. But now, couple of years before, right, 2 years before, the 17,788 standard, 17,789 standards has been updated. So the latest one is ISO IEC 20,123. Okay, this is the standard, ISO standard, in which they come up with the cloud computing vocabulary, definition, and all this kind of thing. So let me do one thing. Let me just show you that. ISO 22, this one. Okay, this is the standard, the new one which has been launched. So generally, if you search like this, without any 1, 2, 3 abbreviation, you can able to see the actual standard here. This is the latest one, ISO 22123, which actually talks about cloud related definition, cloud computing reference, architecture, and everything. Okay, this is a document, the latest standard. Now, whenever we talk about cloud computing, we have something called as characteristics of cloud computing. So when I say characteristics of cloud computing, we can discuss this from two perspectives. One is from ISO perspective, one is from NIST perspective. So from NIST and ISO perspective, everything is somewhat same. In ISO, they have added one extra characteristics. That is it. Let's see what is it. As per the NIST, we have 5 characteristics of cloud computing. How to remember the 5 characteristics of cloud computing? We will use the word BROM. BROM. Right? You can remember this word BROM. So B stands for broad network access. This R stands for rapid elasticity. This R stands for resource pooling. This O stands for on-demand self-service. This M stands for measured service. Now let's see what is broad network access, a rapid elasticity, measured service, on-demand self-service, resource pooling one by one. But if you compare it with ISO, broad network access, measured service, on-demand self-service, rapid elasticity by which we can achieve the proper scalability, resource pooling. But can you see one difference? Here they have added multi-tenancy as the 6th characteristics of cloud computing. Compare with the NIST. The only small change happened in the ISO. Now let's see what is each of the characteristics one by one. First one is broad network access. What is it? For example, we'll take an example of AWS. Okay. And one more thing, CCSP is a vendor neutral certification. In the exam, they are not going to ask you any question specifically related to any vendor, right? So there is not going to be any question related to AWS, Azure, GCP. It is a vendor neutral certification. Okay, it's clear, right? So
Yeah.
they will not ask you about any services related to a particular vendor. But for the discussion sake, I'm just using some provider and their services. For example, right now, Melvin is here. So Melvin is in India. So he is opening an account with AWS. In AWS, we have a service called as S3 service, which is a storage service. Storage service for storing the objects. So what I did, I just created a S3 bucket. Bucket is nothing, it's like a folder which will hold the data. So I put some data inside the bucket. So this bucket is actually located in Mumbai data center, right, within India. Now tomorrow, Melvin is flying to Singapore. In the Singapore location, he's having his MacBook. So using the MacBook, will he be able to access the data which is stored in this Mumbai data center? Answer is yes. If he is authorized to access from any location using any device through the network, he can able to access the data which is stored in the Mumbai data center. It is possible because of this character broad network access. Because what broad network access is, the capabilities are available over the network and access through standard mechanism that promote use by heterogeneous thin or thick clients. That means the resources and the services which is hosted on the cloud can be accessed from anywhere, from any location using any device. Like mobile phones, I can access it. Tablets, I can access. Laptops and workstation, I can access. Because of the kind of network connectivity provided by the CSPs, I can able to access the data from anywhere, any location using any device if I'm authorized. That is what broad network access. Then a rapid elasticity. What is it? First of all, what is elasticity? Can I say, when I say elasticity, it is stretchable and shrinkable. What is it? See, for example, I have 3 books here. So to hold the 3 books, I put a rubber band. Now I have 4th book. So what I did, I stretched the rubber band and slide the 4th book here. So automatically it will stretch itself to hold that 4th book. But when I remove that 4th book, automatically it will shrink back to hold the 3 books. This is what we call it as scalability. Based on the demand, I can scale up, scale down, scale out, scale in. But the scalability achieved because of the characteristics of the rubber band elasticity. So with the help of the elasticity only, we can able to achieve the scalability. Scalability means whenever there is a need, I can go up. When the need is being done, I can scale down. That is scalability. How it is possible? Because of the elasticity nature. That too in the cloud, we can achieve this rapid elasticity very quickly. That is why it is a rapid elasticity. For example, this is my cloud service provider. So I hosted a web app on the cloud. So there is one VM on top of this web app is hosted. So it is a e-commerce site. E-commerce site. So now I'm planning for some 3-day sale. So what will happen when I plan for any 3-day sales, right? Festive sales, newer end sales, something like that. So absolutely for the next 3 days, I know there will be lots of traffic will be generated towards my web app. So I should have certain way or some way to handle that traffic. So what I did, I bring in a load balancer here. In that load balancer, I configure if for this VM1, if the CPU usage goes about 80%, spin another VM2 and share the load. If the CPU usage goes less than 60% for VM1 for 5 minutes, spin off the second VM. So based on the demand, based on the need, I'm just scaling up, scaling down, scaling out, scaling in. How it is possible? Because of the elasticity character provided by the cloud. That is rapid elasticity. The example I have given here is Flipkart. Then we have resource pooling.
Melvin, before we move on, so when we say scale up, scale down, it is from the compute resource perspective, and scale out and scale in is from the
Same thing,
performance, same thing.
not
Okay.
performance. For example, I have a system here, right, which is VM1. When I'm saying scale out, okay, scale out, I'm going to spin another VM. When I say scale in, I'm going to shut down this particular another VM and only one VM will be provided the service. Scaling out, scaling in. Scale up means, for example, now I am having a VM1, which is having the CPU of, what you can say, CPU of 8 cores, 8 GB memory. When I say scale up, we are just going to increase the resources within a VM. For example, to handle the load, I'm going increase the VM CPU to 16 cores, memory to 16 GB. When I'm saying scaling down, I'm just reducing the resources to the previous one, 8 GB CPU, 8 cores like that. So based on the scenario, you'll be using the scaling up, scaling down, scaling out, scaling in. And where you implement it, it's a general concept, but you can implement it not only for compute, you can implement it for any services as well, based on what you want to achieve. But I discuss from the compute perspective.
Okay.
Now it's clear, Arun, right? It's clear,
Yeah,
right?
it's clear.
Then we have resource pooling. So what is resource pooling? When I say resource pooling, we have this pool of resources. Okay. We have this pool of resources in the CSP data center. That pool of resources will be shared with multiple tenants. This pool of resources will be shared with multiple tenants. Only logical isolation between the tenants will be there. That is what resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. But only logical isolation between the tenants will be there. So when we say this characteristic resource pooling, I would say it is beneficial for both the parties, provider and the customer. How? I will tell you how. For example, here we'll write it down. I want to move from point A to point B. So what I did, I book a cab and they're charging me $100 for moving from point A to point B. Okay. But when I book a cab to go from point A to point B, during the time of travel, this car is solely dedicated to Melvin. So they are charging me $100. We'll take this car as an infrastructure which is dedicated to Melvin. During the time of travel, they charge $100. Now, same thing, I want to move from point A to point B. But this time, rather than using a specific separate car, I'm using carpooling app. Okay. So I booked a car. So here what I'm going to do, driver is there, customer 1 is there, customer 2 is there, customer 3 is there. I'm just going to share the car with multiple customers. I'm just sharing the underlying infrastructure with multiple tenants. So now they are charging me with customer 1 $50, customer 2 $50, customer 3 $30. So from the car driver perspective, by sharing the resources, by sharing the car, he is also reaping the profit. As a customer, right? As a customer, Melvin is paying only $50 to achieve his goal of reaching to B by sharing the infrastructure. Same thing in the cloud. The pool of resources is being shared with multiple tenants. By sharing it with multiple tenants, CSP is also reaping the profit by effectively and efficiently using the resources. As a customer, I'll be also using the services and I'm going to pay less for the service compared to the on-prem. That is why resource pooling is always called as a multi-tenancy. What is multi-tenancy? Multi means many, tenants means partition. So cloud provider is there. He has a pool of virtual resources. That virtual resources is being shared with multiple tenants. So tenant 1, tenant 2, tenant 3, tenant 4 is using the resource. But there is a logical isolation between each of the tenants, not physical, logical. That is resource pooling. Is it clear? What is resource pooling?
So from ISO perspective, whether this concept will vary, because there the characteristics are 6 characteristics, right? Resource pooling and also multi-tenancy. They are considering as two.
Resource pooling means sharing the resources with multiple tenants. Because of the resource pooling only, you are having multi-tenancy. They added the multi-tenancy itself as the 6th character. That means multiple tenants will be using the cloud service provider resources. That is what the 6th character they have added. The 6th character is actually a sub-character of resource pooling.
Okay.
Then on-demand self-service. What is on-demand self-service? Here, for example, there is an organization called as XYZ. So I'm working as an admin for XYZ. I'm working as a cloud admin for XYZ. So now there is a business unit 1, business unit 2. They're sending me a requirement. Melvin, we need 10 VMs and I need 2 RDS instance. So now as a cloud admin, I have to create 10 VMs. I have to set up 2 RDS instance. I have to provide it to the customer. Customer means my business units. Now for creating this 10 VMs and 2 RDS, I don't have to put a mail to cloud service provider asking help me to set it up. No. As a cloud administrator, what Melvin can do, he can log into the cloud console as an admin and he'll be creating the 10 VMs and he'll be creating the 2 RDS instance provided to the relevant team. So whenever there is a demand, a requirement, as a customer, I can do the self-service. That is what on-demand self-service. Then we have measured service. In the cloud, everything is measured and metered and charged. So for example, electricity is provided to your house 24 into 7. Are we paying for the 24 into 7 where the electricity is provided? No, right? Whatever you are going to consume, you are going to pay for it. Same thing here, same thing. In the cloud, whatever you are going to consume, you are going to pay for it. For example, I am running a VM, right? For 8 hours per day for 30 days. So what is the configuration of the VM and how much time I'm running it, for how many days I'm running it, based on that they will charge me. For example, I'm using 1 TB of storage in the cloud service provider. So based on how much size I'm using 1 TB, as well as how many times I do the read write, based on certain metrics they'll charge me. So everything in the cloud is measured and metered and it is being charged back to the customer. Previously and a long time back, even when you run the VM for 40 minutes, they will charge it for 1 hour. But nowadays and all, even if you run it for 2 minutes, 3 minutes, minute granular level, they will measure it and they will charge it for you. That is measured service. These are the characteristics of cloud computing, Arun. Do you have any doubts in this? Let me know.
No, nothing.
Okay, if you see a number of minutes of virtual service compute time, amount of disk space, number of function calls, amount of network egress and ingress, based on this metrics, they will measure this metrics, and based on that they will charge you, right? You will receive the bill. Now, so far what I did, I just give you the overall idea about what is or what are the characteristics of cloud computing. This one, broad network access. This one, a rapid elasticity. This one, a resource pooling. This one, on demand self service. This one, measured service. Now, for any organization adapts or migrates to the cloud, these characteristics sometimes can be an advantage and can be a concern, right? For organization which is migrating or going to adapt the cloud, these characteristics might be an advantage or might be a concern. What is it? Let's see that. Not every characteristics is going to be advantage or it's going to be a concern. Certain characteristics, we will see what are they. For example, broad network access. So when I plan for BCP and DRP, what is BCP and DRP? Business continuity planning and disaster recovery planning. When I plan for BCP and DRP by bringing the cloud into the picture, this broad network access capability is an advantage. Is an advantage. Why? BCP addresses the availability, and broad networks is also indirectly addresses availability. Correct? Because the capabilities and resources hosted on the cloud can be accessible from anywhere, from any location. So when you plan for BCP and DRP, these characteristics can be an advantage because both focuses on the availability. But what is the concern? Can I say legal and regulatory concern is there? What is it? For example, I'll take that same scenario. My data is stored within AWS in Mumbai data center. So this data falls under certain legal and regulatory requirement. So this data should be comply with the legal and regulatory requirement. So one of the requirement under the legal regulatory requirement is Restriction of cross-border data transfer. Cross-border data transfer restriction. So this data should not move out of the Indian boundary. It should reside within India as per the legal and regulatory requirement. Now this data is stored in Mumbai data center. Now Melvin is traveling to Singapore. From his MacBook, he is trying to download the data for processing in this location, which is in Singapore, which is against the legal and regulatory requirement. So he is violating the compliance. So that is one of the concern for the organization. Yes, right? So they have to properly understand this and have to get a proper visibility, and they have to control these actions. It should not happen. That is one concern because of the broad network access. Legal and regulatory compliance is a concern. Then rapid elasticity. This elasticity is more from a scalability point of view. Scalability point of view. So to achieve the proper scalability, proper configuration is a must. Even though it will do everything automatically based on the need demand, to happen that to automatically scale up and scale down, you have to properly configure it. And rapid elasticity is achieved because of this character resource pooling. Because if there is no pool of resource available, how I can scale up and scale down when there is a need? So rapid elasticity depends on the resource pooling character. So what is resource pooling? I'll write it down here. Resource pooling benefit is that by sharing the underlying infrastructure, we are paying less for the service. But another concern, right? We know rapid resource pooling means multi-tenancy. This multi-tenancy is one of the biggest concern, biggest security concern for any organization migrating or adapting to the cloud. Yes, right? Because it is like a flat. We have we all mostly living in the flats, right?
Yeah.
House 1, house 2, house 3, house 4, like this. Right? This house 1 is adjacent to house 2, house 3, house 4. But if something happening in the house 2, absolutely the side effect will be felt in the house 1 and house 3 because it is co-located. Same thing in the cloud, as we are sharing the underlying infrastructure, it is one of the biggest security concern. So I have a storage, right? The storage 1 is used by tenant 1. The storage 2 is used by tenant 2. The storage 3 is used by tenant 3. Storage 4 used by tenant 4. So this is a virtualized storage which has been logically partitioned, and multiple tenants will be storing the data here. If something goes wrong, if this isolation fails, what will happen? Tenant 1 can access tenant 2 data, tenant 2 can access tenant 1 data. Like this, data commingling can happen because of the sharing of the underlying resource. So multi-tenancy is always the biggest concern. For any organization migrating to the cloud, always from the security perspective, one of the biggest security concern is multi-tenancy. What is one of the solution for multi-tenancy? One of the solution, encryption. Okay, encryption. In this example, if my data is encrypted here, even if they have access to the encrypted data without the key, they cannot decrypt it. So one of the biggest solution for multi-tenancy problem is encryption.
How about the network isolation? Will it have more weightage over encryption or?
See, as per the CCSP exam perspective, if any question talking about what is one of the biggest control for multi-tenancy, always go with the encryption. That's the ISC square's expectation for the answer. Network isolation, that all comes secondary. First thing is always encryption is one of the best control for multi-tenancy as per the ISC square. So in the exam, you have to answer it like this only. Network isolation is also there, but it is secondary. First thing is always encrypt the data when you move the data to the cloud. Encryption is the first control for multi-tenancy. Okay, Arun, clear, right?
Yeah, clear. Yeah.
Because you have to answer as per the ISC2 expectation as per the book. Then only we can pass this exam. That's what I'm telling you. Yes, first thing is always encrypt the data and move the encrypted data to the cloud. Even if it got breached, I don't have to worry because key is securely managed. Nobody can enable access to the clear text data. Protects. Network isolation, network access control, network security groups, these are all secondary. It can be there. But even if these things are bypassed, chances are that it can be bypassable. The encrypted data, nobody can do nothing. It's a scrambled data.
Yeah.
Then we have 1 minute. Let me clear this. Then we have on-demand self-service. We all know what is on-demand self-service, but what is the concern? Concern is sprawl. What is sprawl? Let me give you an idea. So this is an organization, okay? This is an organization. XYZ. So there is a business unit 1. There is a business unit 2. Now the business unit 1, for their project, right? They are spinning 20 VMs in the cloud, right? It can be AWS or Azure, whatever it is. And business unit 2, for their project, they are having 3 S3 storage buckets and 5 RDS instance and then 10 VMs as well. But the problem is, really this 20 VMs is actually needed for this project, for the business unit 1. Really this 3 S3 storage, 5 RDS, 10 VMs is really needed for the business unit 2 for their project? That is the question. Sometimes what will happen, the employees, whenever there is a requirement, whenever there is a need, they will try to go to the cloud and use the services of the cloud service provider. They'll overconsume. So it might be for this project only 15 VMs is enough, but they're spinning extra 5 VMs. So whatever the resources you use in the cloud, everything, there is a cost is associated with that. So ultimately the organization has to pay the cost. This situation is called as sprawl. Unnecessary proliferation of the cloud services, which can lead to unmanageable situations, which can also lead to a lot of cost for the organization. So that is one of the concern here. So the organization has to put the brake on the employees, like how they should create and how they should use the resources for the cloud. That is why what they will do, they will introduce something called as cloud governance. We will see what is governance in domain 6, but I'll just give you a high level idea. What is governance? Governance is all about policies, the rules which runs the organization. So under the governance only, we have the policies. Policies are the high level statement which reflects the management expectations. Then under the policy only, we will adopt some standard for uniformity. Then under the standard, we have the procedures. We'll have the procedures. This will be discussing in domain 6. But to control this kind of sprawl other issues, first everything should start from cloud governance, policies, okay, standards, procedures. So now if I have all this thing, what will happen? If now there is a requirement of 20 VMs for project A to business unit 1, they will send a request first of all to a relevant team. That team will review whether for this project this 20 VMs is really necessary or not. If not, they will say no, 15 VMs will provide and they will approve it. That request goes to cloud admin. So cloud admin will now create the resource. So by having this kind of procedure, policies and standards under the cloud governance, we can put a brake on the usage of the cloud services inside the organization. So there will not be any over provisioning, anything like that. So which can prevent this situation called as sprawl. Then measured service. I would say that this measured service is very beneficial for senior management. Why? Any idea?
From costing perspective, they will be able to understand like
Yes.
what is the upfront cost estimations kind of details.
Yes. Perfect. See, Measured service is one of the beneficial characteristics for senior management. Why? Because at any point of time, let me clear this. At any point of time, the management people can able to log into the cloud console and they can able to see so far how much resources they have consumed and which business unit has consumed what type of resource and what would be the predictable bill. If they find out that this business unit is consuming too much which is not needed, they can apply and put some brakes on that. For that visibility, we have this character measured service. Like this, from this perspective, you have to know this for the exam. Now, is it clear? Can you answer any question related to this from this perspective?
Yeah.
Okay. Before going for this one, right? Before going for the next topic, can you tell me the answer for some questions? For example, which characteristics of cloud computing will be an advantage when we plan for BCP and DRP with the cloud into the picture?
Is
Which
it the
characteristics of cloud computing will be an advantage when we plan for BCP and DRP?
it will be the resource pooling?
Think for BCP and DRP, which characteristics is an advantage? Broad network access. Because broad network access is also focusing on the availability, BCP and DRP is also focusing on the availability. Which characteristics of cloud computing will be most beneficial for senior management to get the visibility about the usage of the cloud resources?
Measured service.
Perfect. What is one of the biggest security concern for any organization migrating or adopting the cloud?
Data security.
From the 5 characteristics we have to say, right?
Okay.
You should not include anything extra thing because you have to only consider the 5 characteristics. From that you have to say.
Okay.
For any
Multi tenancy.
yeah, multi-tenancies. What is one of the best control for multi-tenancy? Always go for the answer encryption.
Encryption.
Right. Like this, they will frame the questions related to the characteristics in the exam. So don't overthink anything. First point is always remember, don't bring the experience into the picture. Exam is not based on your experience. First point.
Yeah.
Stick to the concept of ISC square. When you stick to the concept of ISC square, it will be very easy to pass this exam. It is not that much tough like CASSP this exam, but it is tricky exam. Tricky means they'll play with the words. If you miss anything, it's gone. One single word. The answer will become wrong. So always focus, read the question multiple times, understand the meaning of the questions, and then map the concept, and based on the concept, give the solution. Okay, now after the definition of cloud computing, after the characteristics of cloud computing, we have service model. So what kind of service you can expect from the provider? That is service model. And always remember, cloud is a shared responsibility model. Okay, shared responsibility model. It is not something like when you move to the cloud, everything will be taken care by the provider. No, it's a shared responsibility model. As a customer, I am always responsible for the GRC, my own data security. As a provider, they'll be always responsible for the physical security and virtualization as well. Virtualization security. But who is responsible for what? That will vary based on the service model. So we have 3 types of service model. One is called as infrastructure as a service. platform as a service, and software as a service. What is infrastructure as a service? In the name itself, you can see I'm just going to rent an infrastructure itself in the form of service. This can be a virtual infrastructure. One example is, can I say VM, virtual machine in the cloud? So what actually comprises a virtual machine? Compute, storage, network, correct?
Yeah.
So compute comprises of what? Virtual CPU and virtual memory. Storage comprises of virtual hard disk. Network comprises of virtual network interface card. So based on my requirement, I'm going to choose the virtual CPU, the memory, virtual hard disk, and the virtual network interface card. And we create a VM. And top of the VM, I'll be installing a OS. That OS is called as what? Guest OS. Guest OS. For example, if you see this particular picture here, let me change the color. This is my on-prem. This is infrastructure as a service. For example, AWS, they're providing EC2, which is one example of infrastructure as a service. Azure, we have Azure VM. That is one example of infrastructure as a service. Right. Google Compute Engine, that is one example of infrastructure as a service. Even AWS S3, you're going to rent the storage itself. That is also infrastructure as a service. But we will take the example of VM. If you see on-prem, this is my data center. Right? This data center, network, storage, servers, virtualization, OS, everything I'm going to manage. But when I go for infrastructure as a service, can you see up to this, it is managed by the vendor. Up to this, it is managed by the vendor. If you see here, the data center, networking, storage, servers, virtualization, these are all managed by the vendor. And top of the virtualization through the console, I'm spinning my guest OS. Guest OS. It can be Windows, it can be Linux, whatever it is. So in my case, it is Windows Server, some 2023. Now on the top of the OS, I install the middleware, runtime, data application, all these things I'm going to manage. I'm going to manage as a customer. This is provider. This is what we call it as a infrastructure as a service. This is what we call it as a shared responsibility model. That is what we used to always say. Whenever you go for any service from the provider, always understand who is responsible for what. Now, if you see this picture, I have taken this from NIST. If you see, I have the hardware, hypervisor, and top of that I install this guest operating system, which is Windows Server 2023. Then inside that middleware and application. This side we have the provider CP. This side we have the customer CC. So hardware, hypervisor, everything who is managing? Provider. But the guest OS and other things which is inside the guest OS, provider does not have any control. But on the customer side, I don't have any control over the hardware because AWS, they build the data center in some location in India. They manage it, operated everything, physical security, everything. Inside that, they have the racks and racks of hardwares and servers. They are managing it. I don't have any control. On top of that, they install the hypervisor for virtualization, which they are managing it. I don't manage it. Am I implementing the hypervisor there? No, nothing. They are managing and maintaining it. As operating system, I can make API calls. I can make request to this hypervisor. But I don't manage it. But from here, the guest operating system and applications middleware, everything I'm going to manage as a customer.
Yeah.
I'm going to manage as a customer. Now tell me one thing. In infrastructure as a service, who is responsible for implementing the patches for the guest OS?
It should be the cloud consumer. They are managing
Absolutely.
the operating system.
Absolutely. In infrastructure as a service, who is going to be having the admin control over the hypervisor?
It will be the cloud service provider.
These keywords you have to remember for the exam: admin control, total control.
Okay.
In infrastructure as a service model, as a cloud customer, where will be having the total control? The answer should be guest operating system. Like this picture, you have to have an idea and a visibility. Then you can see benefits. Whenever any organization migrate or adapt to the public cloud, it is always converting the capex to opex. We are converting the capital expenditure to operating expenditure. That is why we go to the cloud. So very quickly we can deploy the infrastructure, and I'm going to pay only for what I'm going to use. And absolutely, it's a shared responsibility model. Cloud provider is going to manage the underlying infrastructure and the virtualization stack. And this infrastructure as a service, as a customer, we will have the most control. In infrastructure as a service, as a customer, we will have the most control, because I have the full control over the VM, guest operating systems, application, middleware, and everything. But also, I would say for customer, little bit of overhead is there. Okay, overhead. Why? Because I have to create a virtual network. Inside that, I put the VMs. I manage the data. I manage the application. Everything I'm doing it virtually on top of the provider infrastructure. So little bit of overhead is there, and it is model infrastructure as a service model in which the customer has the most control as well. Clear this one? Yes.
Yeah.
Then we have PaaS, platform as a service. What is it? In the name itself, you can see I'm going to run the platform itself in the form of a service. For example, Allies, she is the CEO for a XYZ company. This company actually is into software development, and supporting the applications for the customers. For example, now this XYZ company itself is managing and maintaining a data center, right? And the IT team has built the platform on top of the data center hardware and everything, and they are providing this platform access to the developers so they can develop the code on top of the platform. But now what Alice is thinking as a CEO, my line of business is software development, but why I have to have the headache of managing my own data center? I don't want that. Let's do one thing. Let's ditch this data center and let's go to the cloud, and I can go into rent a platform. So now I can only focus on my line of business, which is software development. I don't have the headache of managing the underlying infrastructure, anything. That is platform as a service. That is platform as a service. If you see this on-prem, I manage everything. But when I go to platform as a service, up to this, it is managed by the provider. Data center, networking, storage, servers, virtualization, OS, middleware, runtime. Up to this, the platform is managed by the vendor. And as a customer, I will have the platform access, and I'll be deploying my applications and the associated data on top of that platform. This is platform as a service. If you see this picture, you'll get the visibility. Hardware, operating system, middleware. Up to this, it is managed by the provider. They are exposing the APIs, libraries, everything to the customers through the platform. As a customer, I'm going to deploy the application using the APIs, libraries exposed by the provider. And this application will be making API calls to the underlying middleware, the platform. So as a cloud customer, from this application level, I have full responsibility. But up to the platform, it is taken care by the provider. Now in platform as a service, who is actually responsible for securing the application?
It should be the Customer.
Customer. In platform as a service, in platform as a service, who is responsible for securely exposing the APIs and the library calls?
A provider, the cloud service provider.
Absolutely provider. Also, when we go for platform as a service, we have to consider certain other aspects as well. Not only platform, for every service model. We will discuss that what it is in the upcoming sessions. Now, same benefits, less capex is involved. Right, just I can quickly deploy the application using the provider tools and the services, libraries, and API calls. Actually, they provide and deliver a robust platform compared to what we have in the in-house as well. Then software as a service. What is software as a service? In the name itself, you can see they are delivering the software itself in the form of service, which I can access it through browsers or any other thin clients. That is software as a service. For example, previously and all to make use of this a Microsoft Office. Microsoft Office. We'll be locally downloading it and we'll be installing it locally on the system. Microsoft Office. But now what we are doing, we're just opening the browser, going to office365.com, and in the browser itself, the software has been loaded and we are using it. So this is one example of software as a service. For example, Salesforce CRM, Gmail, all these are some examples of software as a service. So in software as a service, as a customer, we have very less control. Very less control. In infrastructure as a service, most control. In platform as a service, we will have less control. In software as a service, we will have very less control. In all the three service model as a customer, we are relying on the contract. Contract defines the relationship between the provider and the customer. Okay, provider and the customer. In all the three service model. But in software as a service, we have to rely more on the contract because everything will be taken care by the provider. Just we are consuming the software and customer side certain administrative controls will be provided, which we can do. For example, if you have Office 365, who is actually managing and updating the whole Office 365 stack? Microsoft provider. But as a customer, I have a tenant account, and using the tenant account, I can do the admin side for the tenant, customer side tenant partition. But I am not managing anything. So one small advice here is, point is, when you go for any software as a service, always understand your requirement and always try to make sure that requirement is captured in the contract. If not, try to do the negotiation with the provider. Try to do the negotiation with the provider before signing the contract. That is what software as a service rule. If you see, this picture will give you a good visibility as well. See here, we have hardware, operating system, middleware, and the application. So from the cloud provider perspective, this overall hardware, operating system, middleware, everything is managed by the provider. Even the application, the overall stack, who is managing it, admin level, provider. But as a customer, I have access to the application and they expose limited admin control for the customer to configure their own tenant side. That is it. These are the three service model. If you see here, there's a comparison between the three service model. This is my on-prem. I manage everything. If I go for yes, up to the OS, right? Up to the OS, this is actually wrong, okay? Yeah. From the guest operating system, you will manage, okay? This is wrong actually. From the guest operating system, we will manage. Infrastructure as a service. When I go for platform as a service, actually, from the application, we will manage. Up to the platform, the provider is having responsibility. In software as a service, everything will be managed by the provider. And how is going to back up the data, encrypt the data, everything is based on the contract. It's based on the contract. Can you see this example, pizza as a service?
Yeah.
So I just want to bake pizza. Now, first thing is made at home. So I need a dining table, soda, electric gas, oven, fire. I made my own pizza dough, made my own tomato sauce, toppings, everything I'm doing it at home. Even pizza dough, tomato sauce, toppings, cheese, everything. But when I go for infrastructure as a service, I just bought the pizza dough from the shop, tomato sauce, toppings, cheese from the shop, and using this, I'm going to have, I need the fire, I need the oven, electric gas to bake the pizza as well as soda and dining table to serve it. So up to this, it is managed by the provider. Up from here, I'm taking care of it. Then platform as a service. Now I don't want to bake the pizza. I don't have a oven. I don't want the headache of baking my own pizza using this stuff, using these ingredients. So I go for pass. I just call this particular Domino's people and I just tell my requirements. This is the size of the pizza. This is what the toppings I need. This is my requirement. Deliver it. So I'm not having any headache. They just deliver the pizza as per my requirement to the house. And I need just soda and dining table to serve. But now I even don't want the headache of having a dining table and soda. I just walk to the showroom, right? Pizza Hut or Domino's, and they have a menu card, and I know what is my requirement, what is the need for me, and based on the need, I'll just specify this is what I want. Everything will be taken care. Just I have to understand what is my requirement, and I order it. It will be delivered to my table there, and I took it. That's it. I pay for it. That is software as a service. Very less overhead. The example I have given here. In software as a service, users uses the application service for business process operations. Who manages it? Provider. Platform as a service, I develop, test, deploy the applications on the platform which is provided by the provider. Infrastructure as a service, I create, install, manage services, VMs and everything. And who is going to provide me the basic infrastructure? The provider.
Provider.
And now can you see here, now we have something called a serverless. We know what is platform as a service, but what is serverless? One example of platform as a service is AWS EBS, Elastic Beanstalk, Web App, right? These are all some examples of platform as a service. But what is serverless? Even in
Only
the
the service will be
yes. Come
operating
again,
level
come
of
again,
service.
please.
I mean the particular service from the operating system level, instead of going for the entire
Yes,
running with the entire operating system, just availing the
yes,
service only.
kind of. See, even in the platform as a service, I have to configure the platform, right, from my side. But when I go for serverless, the serverless is something like they provide everything, right? They provide everything. We are just going to run that code on top of that platform. That is serverless. For example, by going for serverless, we can also go for function as a service, right? Function as a service. For example, this is a S3 bucket, okay? S3 from AWS. Now, there is a front-end application. Now in AWS, we have a service called as Lambda, okay? Lambda. In Azure, we call it as functions. That's what totally we call this as a function as a service. So in Lambda is one example of serverless. When I say serverless, it is not something like we will not have any servers underlying and all. We don't manage anything. Even the platform also we don't configure nothing. We don't manage it. Whenever there is a need, we'll just run the code on top of the serverless platform. That is what serverless. For example, there's a Lambda. Now, the users through the application can store the images in the S3 bucket. Okay, S3 bucket. So whenever the image got uploaded to the S3 bucket through the application, this is like a trigger. Once the image has been uploaded for a particular user, it will actually trigger the Lambda service. And the Lambda will run that code. And that code will take that image. It will check whether it's a JPEG or not. If not, it will convert that into JPEG and it will store it into another S3 bucket. So whenever there is a trigger happens, that code will get executed on the Lambda. I'm not managing the Lambda stack or anything. Just I'm running the code on top of it. Whenever the code got executed, they're going to charge me for that. That is serverless. I have a less control over the deployment environment automatically. If multiple users are uploading the images simultaneously, for every user separate Lambda code for every user will be getting parallelly executed. So automatically it will scale. So I don't have to worry about the scalability and all. In platform as a service, I have to worry about the scalability. I have to configure in the platform how it should scale and everything. But here automatically, application code only executes when triggered by certain events. That we call it as serverless. Now, clear, Arun, what is serverless?
Yeah, so the configuration part is managed by the service
Everything
provider
is
itself.
managed by the service provider. Only you have to deploy the code, and that code will be executed when something got invoked or triggered, any event automatically. That is serverless. Right. If you see serverless, what is serverless? Example is function as a service. A cloud computing execution model where the cloud provider dynamically manages the allocation and provisioning of servers hosted as a pay-as-you-go model based on the use. For example, if thousands of events has been invoked, for every event, the separate Lambda code will get executed parallelly. Automatically will scale up and scale down. Automatically. They will take care of it. But when I go for platform as a service, I have to configure and plan for the scalability and everything. So here resources are stateless, servers ephemeral means temporal, and often capable of being triggered by an event. Now, can you give me the answer for these questions one by one?
The choice B and C are same, right? I mean, it's a continuation, right? Uh, there is no C option, I believe. I have
This
to read it.
one, no, this one is actually, they have mistakenly put it as C.
Yeah, that's right.
This
Okay.
will remove it. This is no C. Okay, this is not C. This is actually C, and this is actually D. Okay, this is D.
Okay. I think the choice is A because uh, the choice B and C are wrongly, I mean, starting wrongly as a capability of provider. It should be the capability of consumer to use, right? So eliminating choice B and C, it is between choice A and D, right? So I go with A.
So A is something like capability for customer to use provider's application or running on a cloud infrastructure. The application are accessible from various devices through either a thin client interface such as web browser or program interface. This is the right definition or a true statement of SaaS.
Yeah.
This does not make sense. Capability for product to use, no. Capability for product to use the regulated application, wrong. Capability for customers to deploy their application onto the cloud infrastructure using programming language libraries. Actually, what is this? Is it yes or pass or SaaS? It is not SaaS. What is yes or
It
pass?
is not SaaS, it is PaaS. Deploy their applications onto the cloud infrastructure. So operating system will be managed by the provider and where we will be deploying our applications and we'll be configuring that.
Okay. So absolutely for this D it is platform as a service. Okay.
Yeah.
Now what would be the answer for this one? Next one, true regarding infrastructure as a service. You have to tell me from the below option which is actually true from IaaS perspective.
Yeah. Option A.
So patching and maintenance of OS and applications are typically the responsibility of the customer. Okay. While
Yeah.
patching and maintenance of underlying devices remains the responsibility of the provider.
Yeah, correct.
That is why the answer is A. Because when you go for infrastructure as a service, it is the customer responsibility of patching and maintaining the guest OS. The underlying devices, infrastructure, everything will be taken care by the provider. But B says patching and maintenance of OS and application are typically the responsibility of the provider. No, it is wrong. It's not like that. Patching and maintenance of underlying devices. No, we don't have access to any underlying devices as a customer. Wrong. The customer typically manages monitoring and logging. No, this is also wrong. So the answer is A for alpha. This one.
It should be the contract, that is the C, the service level agreement.
See, Alice is the CEO for a software company. She is considering migrating the operation from the current on-prem legacy environment into the cloud. Which aspect of cloud computing should she be most concerned in terms of security? Security issues.
Okay. Security point of view means then it should be the multi-tenancy.
Absolutely, the answer is multi-tenancy. For any organization migrating or adapting to the cloud, one of the biggest concern related to security is multi-tenancy because of the sharing of the underlying resources and infrastructure. Don't forget this for the exam. This one.
From data perspective, if I go with then the backup, right? So it should
No,
be
you
added.
should not go from any data or any perspective. It's overall high level. Don't think in depth like data or network or something very technical. This is again, it is not a core technical course. Actually, we're talking about technicality here, but this is actually focused for the CISO perspective. CISO is not a core technical person, or a security professional is not going to be a core technical person. You have to think like a manager. You have to think like a business people. If you think very technically, then it is wrong. So it will not be very helpful for passing the exam. So you have to think like a manager. You have to think like a business guy. I am a business guy. I know at cloud. I understand GRC. From that perspective, you have to answer it.
Okay, so from business, then it should be the option D, reduce overall cost.
Absolutely, it is answered because Alice is a CEO. She's
C,
always
okay.
taking care of the business. She always consider everything from the business point of view. She does not have an idea about what is network scalability, offset backup capability, and all. She's not a technical person. She's a CEO for a software company. She is considering because business can only decide whether to go to the cloud or not. Technical person or a CISO cannot decide. CEO is deciding based on the business. CISO is going to support that decision. IT is going to support that decision. So she is considering migrating the operation from the current on-prem to the cloud. So what is probably the biggest factor as a CEO perspective, what she will consider? Okay, going to the cloud, I can reduce the overall cost by outsourcing the administration. I can bring the cost down. I can reap more profit. So that is why the answer is D for Delta.